right, we're doing our chapter review for test number 2. Test review, chapter 2. All right, starting off number 1. Okay, I got it a little too high here. Let's bring it down. All right, we've got 2 points here, P and Q. Find the distance and the midpoint. All right, find the distance and the midpoint. All right, so remember, here's the distance formula. Distance equals x from point 2 minus x from point 1 squared plus y from point 2 minus y from point 1 squared. That's my distance formula. I meant to put a square there. All right, so I just put the numbers in. All right, so on this one, my x in point 2, that'd be 30, minus my x at point, I'm sorry, 9. What am I doing? That's the y. I'm screwing up. It's going to be 9 minus 2. My y in point 2 is 30 minus 25. Okay. Making all these mistakes. I have to quit that. All right, so now that's my radical. Now 9 minus 2. I can punch all that in my calculator all at one time. Now, if you have to break it down, that's fine, but let me show you here. I just punch it straight in all at one time. So I've got parentheses 9 minus 2 parentheses squared plus, and then parentheses 30 minus 25 parentheses squared, and that comes up to 74. Okay, then I got radical 74, and you see that's my answer. It don't break down, but if I try breaking it down, that's going to be 2 times 39. 2 won't break down, and 39 won't break down either. So there's no partners to pull out. So this radical 74 is my answer. Okay. Now, what's the midpoint? All right, the midpoint, here's the midpoint formula. You take your x's and you add them together and divide by 2. And you take your y's and you add them together and divide by 2. Okay, so if I look at my points here, my x's, all right, that's going to be 2 and 9. So that's going to be 2 plus 9 divided by 2. 2 plus 9 is 11. 11 divided by 2 is 11 over 2. Okay. Then I have to do my y's. All right, my y's are 25 and 30. So it's going to be 25 plus 30 divided by 2, which is 55 divided by 2. And neither one of those divides, so we'll just leave it like that. And you can see that's my answer right there. All right, so hopefully that one there, you should be able to get it. All right. All right, now on this one, complete the ordered pairs for the equation, then graph the equation. All right, so this says 0 what? If I put 0 in for x, what would my y value have to be? If I put a 0 there, that's going to be 5 times 0, which is 0. That would go away. So I have 2y equals 10. So I would divide by 2, and y would equal 5. So this would be 0, 5. Okay. Now, if I let y be 0, 2 times 0 would be 0. That would go away. So I would have 5x equals 10. And I would divide both sides by 5. That means x would be 2. Okay, and so here's my x and y intercepts. Okay, this is my y-intercept because x is 0. This is my x-intercept because y is 0. And then I would just plot those on the graph, and of course you just use your graphing tool. But if I plot those, 0, 5, 0, I don't go over any, I go up 5, that'd be there. And then 2, 0, I go over 2, and I don't go up or down any. So that'd be a line that looks like this. Not a very good job, but I think the answer's right here. You can see the answer. You get that right. Okay. All right, let's go to this next one. Number 3. The circle with center 1, 5 and radius 4 has what equation? All right, so 1, 5. So since x is 1, that means in parentheses I'm going to have x minus 1 squared. Since y is 5, that means I'm going to have y minus 5 in parentheses squared. And the radius is 4, so I square that. That's 16. That would be my equation. Okay. Now remember, if one of these was negative, like instead of 1, 5, suppose it said 1, negative 5. Okay, so this would still be x minus 1 squared, but this would be y plus 5 then. Okay, if that was a negative 5, then it'd be y plus 5. Okay. All right, moving right along then. Number 4. All right, match the following equation with this graph. So we have this equation here. Which graph is the right one? Well, now if you look at this, this equals 64, and the square root of 64 is 8. So it means the radius is 8. And if you look at each one of these, they all have the same radius. They're all the same size circle, with the radius being 8. So all we really have to focus on is this part right here. So what's my coordinates of the center? So see how this says x minus 3? That means x value would have to be 3. See how this says y plus 2? That means y would have to be negative 2. So this is my center right there. 3, negative 2. Over 3, down 2 should be right there. This is not right. That's 3, positive 2. No, we're going back to the left. Going back to the left and up. Here it is right here. D. D's my answer. All right, see I'm going over to the right 3 and I'm going down 2. There's the correct center. Okay. Moving right along, number 5. All right, use the graph to determine the open interval in which the function is increasing, if any. All right, increasing. Now remember, increasing, as you go from left to right, it's going up. So it's going to be something that looks like this. As you go from left to right, it's going up, which is this right here. Up until right here, it increases. And look, it goes this way forever. So that means from negative infinity all the way over to, it looks like 0. It's increasing, which is right here. So this function is increasing from negative infinity to 0. What about decreasing? Let's look at that. Decreasing would be this one. So that starts right here at 0 and it goes all the way to positive infinity. So it'd be 0 to infinity. This would be decreasing. Okay. Now, what if it said constant? Which part of this graph is constant? Well, there is no part that says constant. So there is no interval in which it's constant. All right, so there's a little bit of review on the other parts in case it happens to ask that instead on the test. Okay, what about here? Decide whether the relation defined by the graph to the right defines a function. Is this a function? Well, no. If you draw a vertical line, it touches it twice. So no, it's not a function. Okay. And you see it down here. No, it's not a function. All right. Now, what's the domain? All right, domain, remember now that I went to the doctor and I got an x-ray. All right, domain is your x's, range is your y's. So domain is x's, left and right. What's the furthest to the left it goes? What's the furthest to the right it goes? Well, it looks like it goes to 2 right here, furthest to the left. So my domain would be 2, and then it goes to the right forever, infinity. But now it does include 2. We consider this graph including 2, so that would be my domain. Okay, and you see that down here, that's right. Now what's the range of this graph? All right, well range is your y's. Went to the doctor and got an x-ray. Range is my y's. So what's the furthest down it goes, and what's the furthest up it goes? Well, this thing here is going to go down forever. And then it's going to go up forever. So down forever, up forever. And that's my range. Okay, that's like the ugliest graph I've ever drawn in my life. Don't tell nobody that I did that. All right, number 7. Okay, decide whether this graph is that of a function. Well, let's see here. Where can I draw a vertical line and touch it twice? Well, I can't. So it is a function. So yes, this is a function. Nowhere can I draw a vertical line and touch it twice. So it is a function. So it passes the vertical line test. Now, what's the domain? So domain, remember, went to the doctor, got an x-ray. Domain is your x's, range is your y's. So my x values are sideways. What's the furthest to the left this thing goes? Well, this graph is going down, but it's going over forever. And it goes to the right forever. See here, as I go, this thing's going up forever, which means it's going to the right forever. So here's my domain, negative infinity to positive infinity. Okay. And what's my range? Well, look here, this thing's going to go down forever. This here's going to go up forever. So it goes down forever. It goes up forever. So there's my range. Okay. All right, number 8. Decide whether a relation defines y as a function of x. Give the domain and range. Okay. Yeah, this is a function. Now remember, what is not a function? What's not a function? If you have y squared or another even number, like y to the 8th power, this is not a function. Any even power on y. Now it can be on x. You can have x to the 8th power, that's okay, but you can't have a y to the even power. That's not a function. And absolute value bars with y in it. These are the only ones that we may have in this class that are not functions. So do we have that here? No, we don't. So this is a function. This is yes. Okay, it is a function. Now what's the domain? All right, now on the domain, if you look at this, there are no restrictions. Okay, now if you remember, there's restrictions. There's 2 main types of restrictions. One restriction is when you have like 3x plus 5 over 2x minus 1. Down here in the bottom, you can't divide by 0, so you have to exclude that value, which is my 0 here would be positive 1 divided by 2. 1/2 would have to be excluded. I can't have that as my domain. So there's one restriction. Another restriction is if you have a radical, like if you have 4x plus 7 in a radical. This can't be negative in the radical. I can't have a radical with a negative in it. So these would be my 2 restrictions. Okay? I don't have any of that here. So my domain would just be negative infinity to positive infinity. And then my range, well, on this, if x goes to negative infinity, it looks like y is going to go to negative infinity. And if x goes to positive infinity, y will go to positive infinity. So there would be my range. So my domain and my range. Okay. Now, number 9. I've got this function right here. G of x is this. Find g of negative 4. So I'm going to take negative 4 and I'm going to put it in the g function. So it looks like this. Negative 4 squared plus 5 times negative 4 plus 3. And you can just punch that straight in the calculator. The answer should be negative 33, but let's punch it in and see what it says. So here's where a lot of people make mistakes. See, they got this negative out front. People will leave that negative off. That's what happens most times on mistakes. All right, so let's see here. Let's clear this off. We've got this negative, and then in parentheses, negative 4 squared plus 5, and in parentheses, negative 4 again, and then plus 3. And what we got there, negative 33, don't we? So we're in good shape. We got the right answer. Okay. Moving right along. We're on number 10. All right, number 10, graph this linear function. Identify if it's a constant function, and then give the domain and range. Use the graphing tool. Okay, so if I graph this, okay, now if you remember, f of x equals 1/2 x minus 7. This is my slope. This here's my y-intercept. I start here, I go down 7. Right there. And then my slope is 1/2, which means I go up 1 and I go over 2. So there's my 2 points I would use to click on, and that would draw my line. Okay? So that's how you graph it. Now, is this a constant function? No, it's not. Remember now, a constant function goes straight across like this. This is constant. That's not what we have here. So this is not a constant function. Now, what's my domain here? Well, if you look at your graph, it goes left forever, it goes right forever. So my domain is negative infinity to positive infinity. Oh, yeah, right there. Now notice now there's 2 answers here. I've had a couple people that made mistakes on this. They put it in here. See these braces? They don't go in for the braces. The braces would be just for individual values. Like suppose my domain was just 2, 4, 7, and 10. Then I would just put those particular values in there because that's the only ones there are. This goes from negative infinity to positive infinity, so we're typing it in the interval. Now, what's my range? Okay, my range. Well, this thing goes down forever and it goes up forever. So that'd be negative infinity to positive infinity. So it goes in here too. Negative infinity to positive infinity. I wouldn't put it in here because these are individual values. Okay, now if I had a straight line like this right here, straight up and down line, which is undefined slope, here, let me write over here. If I had a straight up and down line like this right here, with this I'm not drawing it very good, but suppose that's straight up and down at negative 16 here. Okay, then that means my range would go down forever, it would go up forever. So it'd be negative infinity to positive infinity. But my domain would just be that one value. So my domain would just be, on that would just be negative 16. Because that's the only x value there is. So that's when you would use these braces for your answer. But we don't have it on this one. We got to do the interval. Okay. 11. Graph the line passing through the given point and having this indicated slope. So we've got this point, we have this slope. Well, let's start with that point, 2, negative 3. 2, negative 3 would be right here. Okay, so you plot the point, and then the slope is negative 5 over 2, which means it goes down 5, and it goes to the right 2. You always go right. If it's positive, you go up. If it's negative, you go down, but always go right so you don't mess up. So I'm going to go down 5, so I'm going to go 1, 2, 3, 4, 5, and I'm going to go over to the right 2, which put the second point here. So here's my line right there. Okay. All right, you can see the answer down here, and you look up there. See, we got the line right. Looks right. Okay. Now, well, that's all I'm doing. It's not asking for a domain, but my domain would be negative infinity to positive infinity. My range would also be negative infinity to positive infinity, but it's not asking that. And about 12. Write an equation of the line through this point, and it has this slope in standard form. Okay, let me get this paper here and we'll write this down. It goes through negative 1, negative 2, and has a slope of 20 over 3. Okay? All right, so I know it's going to be y equals 20 over 3 x plus b. This is my slope-intercept form. But I don't know the y-intercept. But I can figure it out by taking this point and putting it in. This goes in for x, and this goes in for y. Okay, so I take my point, I put it in for x and y. so I can figure out the y-intercept. Well, I multiply these right here, and that's just going to give me negative 20 over 3. And so I would add 20 over 3. This will go away, and b would equal negative 2 plus 20 over 3, which would be 14 over 3. There's my y-intercept. Okay, so that means right here, my line is going to be 20 over 3x plus 14 over 3. This is my equation of the line right there in slope-intercept form. Okay, but it wants it in standard. That's what it's asking for. So again, let's go through this again. There's my point, my slope, so I know it's y equals 20 over 3x plus b, and I take my point and put it in for x and y. I multiply these, then I gotta add it to get rid of it, and there's my b. So it's going to be y equals 20 over x plus 14, 20 over 3x plus 14 over 3. Now to change it to standard, well, I can't have fractions. So I'm going to multiply both sides by 3. So I'm going to have 3y over here equals, when I distribute my 3, well, the 3 will cancel that, which gives me 20x. And when I multiply 3 here, it's going to be at 14. Okay, and then I need my x's and y's both over on the left, so I need to minus 20x. So I have negative 20x plus 3y equals a positive 14 over here. This is gone now. Okay, and that would be done here, except this is negative. My x value can't be negative in standard form. So I just change all my signs. So it's going to be positive 20x minus 3y and negative 14. And there you go. There's my answer right there. Okay, let's see if we got this right here. Okay, oh, I got to put these in. So this should be 20x minus 3y equals negative 14. So this is going to be 20x minus 3y negative 14. And so there you go, 23 negative 14. We got those. Okay. All right, 13. Write the equation in standard form and slope-intercept form of this line described. All right, so it's got to go through 410, and it's got to be parallel to y equals negative 9. All right, y equals negative 9. Look here, there's no x. There's no x, which means it's got to be parallel to the x-axis. It can't touch the x-axis because there's no x in it. All right, so that means 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the line down here like this. Okay. Now, if I want the equation that passes through this point right here, and it's parallel to that, well, that means it's also going to be a horizontal line. And it passes through 10, which is right here. So there's what this line is going to look like. But it's going to be y equals 10. And that would be the same thing in standard form and slope-intercept form. So y equals 10. Okay. What about 14 here? Write an equation in slope-intercept form and in standard form passing through 6, 3 and perpendicular to this. Okay. So look here. X equals negative 9. Okay. There's no y, which means it cannot touch the y-axis. It's a vertical line with undefined slope at x equals negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the line right here. All right, I want a line that's perpendicular to that, it says, which means it's got to be like this, which means it's got to be a horizontal line. Okay, and it's got to go through this point, 6, 3. Which means 1, 2, 3. This is my line right here. It's y equals 3. Okay. All right, so there's those two. All right, 15. Now here's a couple easy ones. If you know these, which one's the graph of this? That's absolute value, and that forms a V right here, H. Okay. On what open interval is it increasing? All right, increasing, again, as you go over left to right, it's going up, which is right here, this part. So that starts right here at 0. It starts right here at 0, and it goes all the way to infinity. So from 0 to infinity. Okay. Go to infinity. All right, there's another one of these. All right, this is f of x equals x to the third. Okay, hopefully you know these, but let's see here. X to the third right here. That's x to the third graph. Okay. What's the range? What's the furthest down it goes? What's the furthest up it goes? Well, it's going to go down forever. It's going to go up forever. So there'll be negative infinity to positive infinity. So you see that right here. Here's none of these. Man, why can't the test be all just this, huh? Which one is the identity function? The identity function is linear. That's this one right here. Or what's the equation? It's just f of x equals x. Now they wrote it backwards, but that's the same thing. 18, we got a piecewise function. All right, so we're going to find all these values here. Okay, so f of negative 3. All right, I have to look over here first and figure out where negative 3 is. Which piece does it belong to? Well, this is my x value. So x is less than or equal to negative 2. That would go in this piece. So I put negative 3 in here. So 4 minus, I'm going to do 4 minus 5 times negative 3, which would be 19. Okay, now f of negative 2. Negative 2 is going to be in that piece also. See, because x is less than or equal to negative 2. So it stays in that piece. So I'm just going to put negative 2 in there. So do 4 minus 5 times negative 2, which is 14. Okay, going on down, f of 3. Now which piece? All right, now 3 is not in there no more because it's not less than negative 2. Let's go to the next one here. All right, 3 would be in here because it's between these two numbers. 3 is between negative 2 and 7. So 4 times 3 would be 12. Okay, I just put 3 in for x right there. What about 6? Which piece would 6 belong in? Well, 6 is between negative 2 and 7, so I put 6 in there. 4 times 6 is 24. And then f of 8, which piece does 8 belong to? And I think it's in this last one, because see, 8 is greater than or equal to 7. So I would put 8 in here. So I'm going to have 5 times 8 plus 3. That's 40 plus 3, 43. And it looks like we got every one of them right. Okay. Now 19 says graph this piecewise function. So we have all these graphs. We have to select which one's the correct one. All right, well, what we're going to do is we're going to look at this transition value when it transitions from this piece to that piece, which is 1. So I'm going to put 1 in for x of this one. So it's going to be negative 2 minus 1, which is negative 3. Okay, see how it equals? It's got the equal to line. This should be colored in. Okay, now when I do this one, put 1 in here. I'm going to have negative 2 plus 2 times 1, which would be 0. So when I put 1 in that one, I get 0. But see, it's not equal to 1 there, which means it's not going to be colored in. So I should have these 2 points, and this one's colored in, that one should not be colored in. So that might tell us a couple that are not the right answer. So let's see here. 1, negative 3, so 1, negative 3 is colored in. There you go, that's colored in. And then 1, 0, right there, it's not colored in. Now, this one could be right. Let's look at the other ones. Same 2 here, if you notice. 1, negative 3 is colored in, and 1, 0 is not, so it could be that one. Or these, now, this is off. This is not right. And this is not right. So it's got to be one of these 2. Okay? Now, all I do is, I go in here, let's pick a value of x that's less than 1, like 0. If I put 0 in there, I got -2 minus 0, which is -2. So 0, -2 should be on the correct graph. So 0, I don't go over any, I go down to, right there it is on this one. Okay. If I do this one here, 0, -2, it's also on that one. So both of these work for that point. Okay, well the defining point is going to be this other part. You see how this goes up and that goes down? All right, so let's go to this piece and let's pick a value of x that's greater than 1, like 2 or 3 or 4 or something. Well, let's try 3. If I put 3 in there, so I've got -2 plus 2 times 3, which would be 4. So when I put 3 in, I get the value of 4. This should be on my graph. Let's see here. 1, 2, 3, 1, 2, 3. Yeah, right here. This is it right here, A. A was right. This was A. See right here on this one, if I put 3, 4 in, 1, 2, 3, 1, 2, 3, 4, see that doesn't go through it. This is wrong. So that's how you determine the piecewise function. You might watch that again if you need to. All right, then we've got, all right, you're going to match these up, column 1 and column 2. All right, so we're taking x squared and we're transitioning it. So I got x minus 10. Now see the minus 10's in the parentheses? All right, that's going to move it horizontal, and it does the opposite, which means it's going to move it to the right 10. So it moves to the right 10. Which one? Right here. This is D. Okay, here, that's right down here. This first one is D. Okay. Now number 2. All right, see the difference here on these two? See how the minus 10's in the parentheses? That's getting squared along with the x. So that's going to affect it horizontally, the opposite way. But see, this is not in the parentheses. So that's just going to make it go up vertical, or down in this case. See, it's negative. So it's going to make it go down 10, which is C. Okay, now look here at my 10. 10's a multiplier. That's going to stretch it. So it's going to be a vertical stretch. Right here, B. Okay, now here you go again. Here's the same deal we had in these first two. See that they both have plus 10, but see how this is in the parentheses with the x, and it's getting squared along with the x. That's going to be horizontal, and it goes the opposite direction. So since that's plus, it's going to make it go this way, 10, to the left, A. And then right here, this is not getting squared, which means it's going to affect it vertical, which means it's plus 10, so it's going to go up 10. That's E. Okay. So let's look here. We got D, C, B, A, E. D, C, B, A, E. We're good. All right, 21 here. So we might need to cut these graphs off like I've done before here. Let's do this. All right. I think we can see them all a little bit. Okay. Make sure you get them on there where you see them all. Okay. So we're taking the x squared function and we're doing these transformations. All right, so which graph is this one? Now notice here on the first one, I'm plusing 3, and see it's not in parentheses with the x getting squared. So this is just going to be going up 3. So this should just go up 3 here. Up 3, looks like B here. B. See how this is going up 3? All right, what about this one? All right, look here. See, this is minus 3, which is going to go down 3. Which one goes down 3? Right here, A. Okay. Now, look here. I've got the plus 3 in parentheses. So you got to know the difference between these two right here. You got to know the difference here. This is going to go horizontal because it's getting squared with the x. This is not getting squared with the x. That's going to affect it horizontally, which goes the opposite way. So it's going to go this way to the left. All right, so to the left, 3. Here, G. All right, so this is G. Bag, B-A-G, bag. Okay. Now, here you go. This is in parentheses, but it's minus, which is going to make it go this way, 3. Okay, that's C. C. Okay, now what's the correct graph of this one? All right, we got a multiplier, which is going to stretch it. So it's going to make it get real tall and skinny. Right there, F. Okay. All right, look here. We got a multiplier, which is going to stretch it, make it skinny, but then we got a negative also, which is going to make it flip downward. Flip downward right here, D. I'm getting skinny. See right here, D, it gets skinny, and it's going downward. All right, then these last 3 have 2 transformations going on. All right, so this one here, this is horizontal. See, if it's in the parentheses, these are all horizontals. And then these over here are verticals. So this is going to go the opposite, so it's going to go to the right 3 and then up 2. So this is going to the right 3 and up 2. Right there, H. This one's going to go to the left 3. See, it's plus 3, so it's going to go to the left 3, and it's going to go up 2. So to the left 3, up 2, looks like E right here. And this one's going to go to the left 3. It's going to go down 2. Looks like I down here. All right, so there you go. If you have any questions about these, please contact me. I'll help you all I can. All right. Oh, we didn't check our answer here. Here's our answers. Let's put it back on there. B, A, G, C, F, D, H, E, I. We're good. Check. Got 100. Good job, Mr. Everly. All right, 22. Without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis, the y-axis. We skipped this, so I'm going to take this off. Okay, we'll skip this, but this is symmetric about the y-axis is what it is, but I'll take that off. I didn't realize that was on there because we kind of skipped over that. Okay. Now graph this one. Okay. So this is going to be a parabola because it's x squared. So it's going to make a parabola like this. But we got transformations. We've got, this is going to go, this is horizontal, which is going to make it go to the right 2. This will make it go down 2. And this is going to stretch it, vertical stretch of 2. And on this, it'll make those boxes. And when you do it, it'll form this graph. And so like if I do this, I'm going to go to the right 2, and then I'm going to go down 2. So here's where my vertex would be. And it's going to stretch it. So when I go over 1, it's going to go up 2. So it's going to look something like this right here. It's going to be kind of thin. And that's what it'll look like. Okay, you can see the graph down there is kind of similar. Tell you what we're going to do. Let me get my computer fired up here. And we'll do one of these on the computer, number 23. All right, let's go to the computer. All right. So graph the following, or we're just going to click the graph. It's a parabola, so we're going to click the parabola. And we're just going to click the screen, these boxes come on. So you just have to relay what goes in these boxes. So we do have a vertical stretch right here too. So my vertical stretch, let's just type us a 2 in there. Okay, there is no horizontal stretch. That would be if you had a multiplier inside here, but we haven't done any of those. That's not really a common thing. Now right here, this -3, that's horizontal shift. And remember, it does the opposite. So this -3 makes us go to the right 3. So horizontal shift to the right 3, so it's just a +3. And then right here is vertical shift. It's going down 6. So right here I'm going to put a -6. Okay, I'll click this box, and then that you can see it's going to the right 3, it's going down 6, and it's stretched. You can see it gets more narrow than normal. So we're good to go. Okay. All right. I think there's one more, and it might be on the computer also. No, we'll come back. All right. This is the last problem. Okay, which is 24, but it's going to be 23 now because I'm taking that one off. Okay, so here's f of x, g of x. Find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Okay, so f plus g of x, that's going to be f of x plus g of x, which is going to be f of x, that's 4x plus 3, plus my g of x, which is 2x minus 5. And I just add those together. So 4x plus 2x would be 6x. And then 3 plus -5 would be -2. All right, that should be my answer right there. Can you see it down here? That's right. Okay, now this next one, f minus g of x, that's going to be f of x minus g of x. All right, f of x, 4x plus 3, minus g of x, 2x minus 5. All right, now here you want to distribute this minus. You want to distribute the minus and change this to plus. So it changes these to opposites. And now I can just add them. So 4x plus -2x would be 2x. And then 3 plus 5 would be 8. Okay, we're good on that. All right, so you see the first two on here. Got those right. All right, now the next one, we're doing fg of x. So this is f of x times g of x. All right, so it's going to be f of x, 4x plus 3, times g of x, which is 2x minus 5. And I'm going to multiply them. Well, I'm going to make me a multiplication box underneath this. Put this guy over to the side. And I'm going to multiply these. All right, let me move this up a little bit more. All right, so I'm going to have 4x times 2x, which is 8x squared. Here I've got 3 times 2x, which is 6x. Then I've got 4x times -5, which is -20x. And I've got 3 times -5, which is -15. These two are like terms. So it looks like I got 8x squared. These two add together, so 6 plus -20 would be -14x. And they got -15. Okay, and that's my answer down here, so I'm good there. And the last one is f divided by g of x. And usually you can't do this division, so you just have to write the f function, which was 4x plus 3 on top, and then over the g function, which is 2x minus 5 on the bottom. All right, so you can see how that's wrote here. Okay, and then your domains of all these, there's no issues here, no issues here, no issues there. So all three of these are going to be negative infinity to positive infinity because there's no restrictions like we've talked about before. But this bottom one here, this f divided by g, we've got a restriction here. We cannot divide by 0, so my 0 for this has to be excluded. So now to find the 0, we've done this a few times, it's going to be a positive 5 divided by 2. So 5 halves is my 0 here, and I have to exclude that value from the domain. So the way I do that, normally it's negative infinity to positive infinity, but I got to exclude this, which means I'm going to go negative infinity to that 5 halves, and I'm going to exclude it on the left, and then I'm going to exclude it on the right. And so that takes out my 5/2, which you can see that down here. Okay. So we got it, man. This is our test review for Chapter 2. So if you have any questions, please contact me. I'll help you all I can, and I hope you just knock out this test. Have a great day.